If n is a positive integer that is greater than 1 and a is a real number, then n square root a equals 1 a to the power of 1 divided by n, where n is the index, a is the radicand, the square root sign is the radical. And remember, the left side is called radical form, and the right side is exponential form. Usually when we have square roots, the radicand isn't shown, so we'll drop the index isn't shown, so we'll drop the 2. So there, you should always know there's an invisible 2 if you just see a square root sign. So in this example, we have 4 square root 16, and we're going to 16 to the power of 1 over 4. And then 10 square root 8x, we'll have 8x to the power of 1 divided by 10. Basically, the index turns into the denominator of the exponent. And for this one, we have square root x squared plus y squared, that should be y squared, to the power of 1 divided by 2. Everything inside the radical is set to, like, everything inside of the radical has the exponent sign. So if we have 8x, 8 times x to the power of 1 over 10, 8 is going to be outside of that because 8 doesn't have the exponent. X does. Now, if there's a bracket around the two of them, then yes, 8x would be on the inside. And so if we want to evaluate this, if you have a question that says evaluate, how would you do that? Basically, you want to actually have an answer, like a real number. So what we're going to have is 16 to the power of 1 over 2 equals a 4. For this one, 16 to the power of 1 over 4 is 2. You can just punch that into your calculator, but you need to find something that gets to the power of whatever the index is, and that's basically going to be the answer. So for 16 to the power of, or 4 to the power of 4 square root 16, it's going to be 2 to the power of 4 equals 16. And again, for 5 square root 243, we have the same sort of solution. At this point, it becomes fairly obvious what we're doing. If there's a negative, that doesn't change anything, really. We're going to be left with negative 125 to the power of 1 divided by 3. You can just punch that into your calculator. When you get huge numbers like this, you can just punch it into your calculator, realistically. But it's important to be able to change it from radical form to exponential form. And for this one, there's technically not an answer, because if it's a negative and if there's a negative number and there's a positive exponent, like a even number exponent, you'll always have like a positive answer. So this one doesn't really work technically. The answer, you'd get 16. Like if we had negative 2 to the power of 4, we would get like just 16 because there's a positive exponent. If we wanted to have a negative answer, we would put the negative sign outside of the radical. And then we would always have, no matter what the exponent is, we'll always have a negative number because the negative sign is outside of the brackets, outside of the radical, and it's as simple as that. now we can start looking at some properties, just to review them. Again, n square root a to the power of n, that sort of gets rid of the square root sign, because the exponent inside of the basically if the exponent inside of the radical matches the index, the radical can be you can get rid of the radical completely and just have the number. And this one where it's n square root ab, that this is just letting you know that it's we can break it up into two separate radicals if we want to, for any purposes that we need. And again, if we're dividing, it's just letting you know that the numerator and the denominator are square roots. So write that down. Remember that. So if we have to simplify, this is how we would simplify a question like this. We kind of want the radical to be what's considered a perfect square. So basically, we'll just break it up. We'll break the y7. We'll take 1 out, and then it's y6. Then we'll break the y6 into 3 times 2. So we'll have a 3 inside of it and a 2 on the outside. Why do we do that? Because if the exponent on the inside matches the index, remember there's an invisible 2, then we can actually release it. So the y3 can be released from the radical. And in this one, the square root sign is 9. We can't take it out. Really, you can do one step for this. You can just divide it. You can just divide it by the like what they both can, the multiple of both of these. So really, we could just divide it by 3. But I like showing this method because it really lets you know what's going on at a deeper level. So we turn that into exponent form, we get that. Then we multiply the exponents because there's a bracket, and then we simplify, and we can end up with sort of an easier simplified answer. And now for this one, because there's actually like a real number, we're going to divide it. Like, we're going to take out as much as we can, and we're going to put the leftover sort of in a bracket. So we divided 9 by 2, and we took out one of the y's. And we broke the x to the power of 6 just so we could have a 2 on the outside, because 3 times 2 equals 6. And the y, we broke it up into 5 and 2. And remember, we have the 2 on the outside of the bracket because we want the exponent on the inside to match the index. Remember, there's an invisible 2. And this extra step where I'm just drawing a bunch of radicals, you don't really have to do this step, but some people find it easier to understand this way. So this is just to let you know that each sort of, like, what's a separate term. So 9 is like its own term. X to the x3 x to the power of 3 squared is its own term. And so on. And then we look at what sort of matches that. So the 9 is put to the power of 1 over 2, and the exponents to get out, they are simply just whatever's inside the bracket actually is released from the radical. So in this one, we divide 32. We can divide 32 by 2. So we have 16. And 9, we can take out 1. So, and the y, we can take out 1 as well. And 12 will leave because that's a perfect multiple of 4. And so all the leftovers are going to leave in a bracket. And so if we, again, I'll just make a bunch of separate radicals, just to let you know what is its own thing. And so what do you think? 16 will have to be put to the power of 1 over 4, which you could solve by just using a calculator, or just if you already know. And basically, remember, we just need the exponent on the inside, if it's a variable, to match the index. So 16 to the power of 1 over 4, that's 2. X squared, and we'll just have y, because remember, the exponent on the inside of that matched perfectly with the index. And the leftovers are the ones that just they will stay inside of the radical. So we're left with this solution. Similar method, we are going to put everything that we can find that's sort of a multiple of 5, we leave there, and all the leftovers we'll leave in brackets by themselves. Because 4 is less than the index, there's no hope of it being able to be taken out. So it'll be inside of that sort of leftovers bracket that we've made. And we have x squared to the power of 5, because 2 times 5 equals 10, just like the x to the 10 that we have. And 4 times 5 equals 20. And remember, we have the exponents for each variable matching the index, because that's the only way we'll be able to take it out of the square root sign, so that we can simplify. And again, you don't have to do this extra step. You could easily just do 10x divided by 5 and have the answer, but I like to break it down. You could do z20 divided by 5 equals 4. You can get an answer right away. But if you really, I just want to show you really what's going on. And we're left with that solution. And so if we have these two radicals, they're multiplying by each other. If there's no sign and they're just right beside each other, they're multiplying. And if they're multiplying, we can combine them. And so it will look something like this. Because both of their indexes are the same, we can just put them under the same radical. So the index stays the same because they start off with the same index, which is 3. Then 9 times 6 is 54. X squared times x squared is x to the 4. Remember, they actually add. The exponents add. And now we can actually divide 54 by 2. So we're left with 27. And then we can just leave one x out, and we do that, and the leftovers will be left in the bracket, and we do that again. Why? So that the exponent on the inside matches the index, which is 3. And again, we're just going to turn everything into its own square roots. So 27 will have to be set to the power of 1 divided by 3. So it'll be 27 to the power of 1 divided by 3 if we want to take it out, which is a nice round number like 3. And the x comes out because it has the same exponent as the index. And so we're left with this solution. This is another skill that's very important, especially with dealing with radicals, but just any high school level even of mathematics. What we're going to do is we're going to separate the like terms. So they both have x's, 4x plus 9x. They both have x. We separate the x's. We add the 4 and the 9 together, and we end up with 13x. With 3x minus 11x minus 11x, we'll do the exact same thing. So we'll have 3 minus 11, and we'll multiply that by x, and then we'll subtract 11 from 3. So we'll end up with minus 8. So in this solution, we would do in this question, we'll do the exact same thing. We're adding these radicals, so we're going to separate the like terms. They both have square root x, so square root x will be outside. Then we add these two together, and we multiply them by the square root x. And if we have 3 times 10 to the power, if we do 3 times 10 radical 5 minus 11, 10 square root 5, we'll do the exact same thing. The math sort of speaks for itself. The 3 minus the 11 and the like terms, which is 10 square root 5, will be outside of the brackets. We'll solve inside of the brackets, and then we'll multiply it by what's outside of the bracket. This is the FOIL method, basically where you multiply everything on the outside by everything on the inside. So the square root x times minus 5 plus 2 times square root x. So yeah, just pause this and sort of try to look at what's really going on. So we'll break that down if you did not understand this. This is a very important thing to understand. If we have something like this, we're going to minus 3 square root x by everything in the other bracket. Then we're going to multiply minus square root 5 times everything in the other bracket. So if we do the first term on the left times the first term on the right, we end up with 6 times square root x squared. And we'll do this so on, like 3 times square root x times minus 5 square root y minus square root y times 2 times square root x minus square root y times minus 5 square root y, and we end up with these solutions. Then we combine like terms after that. So the x squared from 6 square root x, it just gets out of the square root sign because the exponent matches. And then in this side, I'm just simplifying it so you understand what's going on. The minus 15 square root xy is just that. And that's going to be combined with the minus 2 square root xy. So minus 15 minus 2 is minus 17. And yeah, we just combine like terms. And yeah, we're left with something like that. And we're going to use the same method here as well. Feel free to pause at any point to really verify what's going on. So the x squared will be outside of its square root sign, and we're just left with this. Because when we combine the like terms, the tens sort of x themselves out. Now, this is a quick way of getting answers. If you see something that looks like a plus b times a minus b, or a plus b times a plus b, you'll end up with solutions like this pretty much every single time. So just try to remember these or write these down. They become very intuitive after a while. So if we have to rationalize the denominator, all we're doing is getting rid of the square root sign in the denominator. So we're going to need to find a number that turns square root x, that gets square root x out of its square root sign. So we multiply it by square root x. And whatever we do to the top, we do to the bottom. And when we do that, we have x squared. This is perfect because now the exponent matches the index. And now we're left with x, because the x squared is now out of the square root sign, because the x squared matches the invisible 2 that's there. So if we have something like this, where it just is a giant square root sign, and we have 2 divided by x to the power of 3, that's a 3, just a reminder, this is what it really means. We haven't changed anything really, we're just showing it in a different way. So the bottom is also to the square root. Now what we're going to need to do is we're going to need to find something that makes x to the 3 match the index, which is 5. We do that by multiplying the top of the bottom by 5 square root x squared, because x squared times x to the 3 equals x to the 5. X to the power of 5 now matches the index. Because it matches the index, we've successfully rationalized the denominator. The square root sign will now disappear, and we'll be left with x. And remember, whatever we do to the top, we must do to the bottom as well. For something with like a plus or minus sign, what we're going to do here is remember sort of those quick things I told you to write down. We're going to use that method. We're going to just change the sign. We're simply just going to change the sign so that we don't have like some long answer. So we're going to do 3 plus square root x. You can do the long FOIL method to see if it's right, but if you remember the very quick method, you can simply just do this. 3 times 3 is 9. Square root x times minus square root x is minus x. And the same with this. We're just going to change the sign. We're going to multiply the top and the bottom by 4 times square root x. Four square root x plus 3x, or minus 3x. Just change the sign. Just all you're going to do is change the sign. And when we change the sign, we remember, because they have different signs but they have the exact same numbers, the radicals are going to disappear. And the numbers themselves are going to multiply. So we're going to have 4 times 4. And then we're going to have the square root signs. So we're just going to have 3 for the denominator. I remember the top, whatever we do to the bottom, we do to the top. 4 times 4, 16. The x's get out. Whatever's inside of a radical is now out of the radical sign.